refraction at a spherical surface. This is actually single spherical surface. So while using the Snell's law on single refracting surface, you will get a equation in terms of u, v and the refractive index of both the materials in terms of r, that is the radius of curvature of the single curved surface. Okay, single curved surface, which we will use to derive the value of u and v in terms of r for two curved surfaces. In this we will use angle I equals angle NOM plus angle NCM. These two will be equals to angle I by exterior angles. Angle NOM and angle NCM equals to angle I. Similarly, angle NCM equals angle R plus angle NIC from exterior angle theorem. From that we can rearrange for R as equals to angle NCM minus angle NIC. From Snell's law we will write refractive index of first medium with respect to second medium as mu2 upon mu1 with respect to vacuum. Rearranging them for small angle, sin I equals to I. Okay, we can write instead of sin I, cross multiplying mu1 into sin I goes to mu2 into sin R. And instead of I we can write, here we have written this, so that sin I is I, sin R is R. Instead of angle I we can write angle NOM plus angle NCM. Okay, we can substitute for R also. Instead of writing angle NOM, we can write angle NOM means what? Angle theta, which is equals to opposite upon adjacent, that is NM upon OM. We can write for angle NOM, angle NOM equals theta, which is also equals to tan theta, which is also equals to NM upon OM. Okay, so angle NOM equals this. Similarly, rearranging for NCM, opposite upon adjacent, and similarly for NCM, opposite upon adjacent, and angle NIC also, NM upon MI, NCM as NM upon MC. Okay, now then we have to simplify further. NM gets common and cancel. Instead of OM we can write on the left hand side the distances are negative, so we have written minus u1 upon, yes, we can write it as, take this term on this side as positive. Okay, writing this here, this taking term on the left hand side, just substituting for CM and MI. What is CM? CM is plus R. What is MI? It is plus V. Okay, so CM is plus R, MI is plus V, CM is again plus R. Substituting and taking out common, we have got this formula. In this formula we have seen minus U1, that is the first medium, that is from where incident light is coming, and then second medium where the refracted light is going. So first medium minus upon its object length, second medium upon its image length. Difference in refractive index, take it as second medium minus first medium upon its curved surface. So this formula you will use and find the refractive index of, or find the focal length of this lens. So lens makers are using this to find the find the focal length in terms of radius of curvature also. So how they are using it, let's consider this. To find the focal length of this lens, we are considering these formed by two curved surfaces, first one and second one. This is a curved surface, then this will be the first side. In this case, take the object as OB present here, take a normal, meet it to normal always comes from center of the curvature. So perpendicular we have to draw Angle of incidence is with the normal. Also with the normal there is angle of refraction. This is the radius of curvature. Okay, we have named O, B, C1 and I1. C1 is first center of curvature of first surface. I1 is image formed at the because of first surface. So we are applying this law that we have just derived. What is that? Minus of first medium, minus of refractive index of first medium plus refractive index of second medium. Okay, yes. So now we will see minus of refractive index of first medium upon its distance. How much it is? OB. So we have written in on the other side it is negative, so we have taken minus OB plus mu2 second medium into its refractive index B I1 is equals to a difference in refractive index mu2 minus mu1 upon its distance. What is the radius of curvature? Plus R1. Okay, you can write BC1, that is the radius of curvature. We have written BC1 and on the right hand side it is positive. Now we understood this? Yes. Now what we are going to do, we are considering this part of the ray as object. Okay, first this was object and this was the image. Now we are considering this as the object and its image will be formed after this refracting surface here. So this part is object. If this is object, then this would also have been meeting here, which is again the object. So this part is the object and it forms the image DI. So this ray is a object and this ray is the image, because we are talking about this part here, and now it is going to be refracted from this surface. We are considering single surface first and then using this formula, because this is for single surface. So consider this as the object for this interface. So object's length will be DI. Now we will use this formula, first medium upon object length. What is the first medium? This is the first medium, mu2. So minus of first medium, minus of refractive index of first medium upon its object length, that will be DI1 plus second medium. Now in second medium we have air, so we have mu1, or this medium mu1 upon its length. Its image length is DI. Image length is plus DI because it is on the positive side. And difference in which it is going from which medium to which medium? Okay, second medium minus first medium, that is mu1 minus mu2 upon the radius of curvature. Radius of curvature is on left hand side, that is this one, so minus dc2 or minus r2. Now adding both these equations, we have written here, see, BI and BI1, that is this distance, and DI1, that is this distance. So BI1 and DI1, and this is mu2 and minus mu2, so they both consider it as equal for thin lens. Okay, so BI1 and DI1 mean nothing but the same, but this produced image, would be produced image. Okay, this is not existing actually, because we have not considered to. Actually this BI1 and DI1 are as if this surface would not exist, then this would have come and meet here. So this is actually BI1 D1 are part of this surface. In actual ray, the ray would be coming like this, going like this, and then coming back. So this is part we don't consider, right? So this is formed due to BI1 and DI1, which is again subtracted. For thin lens, BI1 and DI1 are same, so these both get cancelled. So now what is this OB? We have written here, DI we have written here. Taking out this common, mu2 minus mu1, minus goes up and it makes us mu2 minus mu1. Take common, BC1 plus DC2. Okay, now what is OB? OB is nothing but object length. Okay, and what is DI? DI is nothing but our image length, and this formula is formed in terms of object length and image length. Now we will use one shortcut, that is if the object is kept at infinity, then image is formed at focus. So this formula is what? U1 upon OB becomes U1 upon infinity. So what do we have here? Mu1 upon infinity plus mu1 upon image is formed at focus, and again it gives you all this right hand side part. That is what? Mu2 minus mu1 upon 1 by bc1 plus 1 by dc2. Now what we have to do? Anything upon infinity is 0, so we don't write this term. This is written exactly down. What is bc1? It is nothing but plus r1. What is b2? dc2 is nothing but minus of r2 because it is on the opposite side. Solving this, taking mu1 at the denominator here, and mu1 minus mu1 is 1. You can write this term as mu2 with respect to 1.